Global Governance Futures is brought to you from the Global Governance Institute at University College London. This is a podcast about the challenges facing humanity and possible global responses. How does the world hang together? What has gone wrong? And what has global governance got to do with it? To learn more, please visit ucl.ac.uk/global-governance.
In the summer of 2023, I visited the UCL Astronomical Observatory for a tour led by its director, Professor Giorgio Savini. The observatory itself is well worth a look, but it was a lively conversation on the sidelines with Giorgio on the subject of space governance which really stayed with me. Clearly, all is not well. In fact, it's all gone a bit Wild West. Whether it's SpaceX dominating orbital slots or countries testing anti-satellite ballistic missiles and potentially making space exploration unviable forever, there appears to be no shortage of demand for governance in this area, and yet governance remains in short supply. As we sketch out in this conversation, extraordinary feats of engineering in satellite technology and space exploration intersect in complex ways with political issues of international cooperation and security, nation-state competition over dual-use technologies, and the contested status of space as a final frontier for colonization versus its recognition under international law as humanity's common heritage.
Space has become like the seventh continent in a way. As scientists, we think of it as such a precious thing, such a precious resource that you would argue the United Nations needs to get their act together.
This is Imperfect Utopias or Bust, Global Governance Futures. Professor Giorgio Savini is Professor of Astrophysics at University College London, specialising in instrumentation for space exploration. We spoke with him in April 2024.
Brilliant. Well, it's great to have you here with us, Giorgio, on the podcast. This follows a very enjoyable tour of the UCL Observatory last year, where we also ended up having a great chat on the sidelines about space governance. Space governance is a topic which doesn't receive much attention in the mainstream of global governance scholarship, but I think it is actually beginning to get some traction, particularly in light of what we might call the militarization of space. But it's still quite a kind of boutique topic for a lot of scholars and students. So I was really actually keen to bring this topic onto the podcast. And I think it's really interesting to engage space governance from the perspective of someone who's actually deeply embedded working in the field of space technology. So, you're a leading expert in astrophysics, specifically focused on instrumentation in satellites. I thought it was really, really interesting to try and get a sense of how the engineers have experienced space governance or space regulation or the lack of space regulation. So thanks very much for being here, Giorgio. But before we get stuck into that, perhaps you could just tell us a bit about yourself. So your trajectory, how you found yourself working in this field.
Okay, thank you very much for having me. Yes, I'm by training, I'm an astrophysicist, but as you rightly pointed out, I specialize in instrumentation. So I sit in the physics and astronomy department, but technically the roles I have are almost akin as an engineer to some degree. How I got here is more like one of those roller coaster things that you sit on the top and you're not quite sure where you come out the bottom. But it's always been about solving problems and doing things that you're passionate about. So that got me where we are, which is working on space telescopes and space instrumentation. And I think to some degree, as you point out, as someone who works on space projects, governance of space and the laws which affect things in space, they're kind of on a level which we often consider to be not far removed, but we're like little ants working on projects on things, and it's always the problem at hand rather than the greater vision, at least at the early stages. And as you get to do one mission and then another small project and a large project, then you start to see the big picture emerge. And when you start planning for the new cohorts and you start teaching students who will be where you are in 1 or 2 decades time, and you think, well, hold on a minute, you have to actually start looking at what the big picture is and make sure that, you're not, the big picture isn't spoiled for the next generation, and also that, things are done appropriately, in an appropriate way according to international laws and stuff. So yeah, it does become very relevant at some point.
Yeah, and I was curious to ask, I mean, when did you first really become engaged with the technical world of satellites and objects being launched into space?
So let's put it this way. When I did my degree in physics, the group where I did my thesis, my last project, this is in Italy, by the way, was on ground-based telescopes. So it was, your average astronomy and astrophysics instrumentation student. After that, during my PhD, the topic of interest, which was a specific one about experimental cosmology, eventually brought me into the UK, in Cardiff, where we were building the Planck satellite, which was a European Space Agency cornerstone mission. And at that time, in that particular group, they were building both Planck, and they were working on the hardware and software for another satellite, which was the Herschel Space Observatory. So inevitably, I kind of got sucked into these other projects, which were space-based projects. And in that environment, Cardiff University was quite a crossroads for far infrared instrumentation at the time. And so I ended up working on a whole bunch of different projects. And then from there, I moved to UCL, where I got into contact with other projects. And I met Giovanna Tinetti, who is the PI of ARIEL, who was also an academic at UCL. And I got involved in other stuff. So different science, but still space missions. And, as you start building expertise in things, you suddenly get called back. Another project which I'm involved with, which I didn't expect to, because I thought I'd left the cosmology environment, was Lightbird, which is a JAXA-led, Japanese Space Agency-led project. And I thought I'd done with that topic, but having worked on Planck, they said, well, we could really use some extra expertise. And so, that's why the roller coaster comparison.
Right. Yeah. So that would have been in the 1990s, I would imagine.
Oh, Jesus, I'm not that old. I went to uni in 1993. No. It's Planck was launched in 2009 and served its purpose until 2013. And a year later, Herschel also ended. Lightbird is in the works. ARIEL will be launched before then. So we're working on ARIEL at the moment, which will be launched in 2029. And Lightbird is likely going to be launched in 2032.
Okay, right, yeah. So I was reading the stats. Apparently, in 2010, 120 objects were launched into space.
Okay,
and
I didn't know
that. 2021, 1,800 objects were launched into space. So there's been an incredible acceleration in terms of launching these satellites and other objects into space. So when you talk about the big picture, I imagine when you sort of first engaged in this sector, it really was about the technical in collaboration among engineers and experts from, I imagine, all over the world, focused on fixing these problems, solving these problems, making these systems, which are obviously sort of critical infrastructure systems for industrial civilization, making sure that they all work appropriately. Was space regulation and space governance part of that context? And if so, in what way?
Well, I would probably say that, if we go back to that 2010, early days when I was already involved in space, but I wouldn't, that was far removed from what I would work on, because, it would be probably the backbone that what propped up the system that we were working into. So, a lot of engineers, that the only few probably people who I was in contact with who would have to deal with are either sort of the management level of the European Space Agency or the UK Space Agency in the specific, or possibly some of the project managers that would have to be aware of certain regulations in order for the spacecraft to be compliant. So, there are things like fuel, mass loss, deorbiting, these things that percolate their way through to the hardware that you're designing. But otherwise, people who are working on specific physical aspects of performance, such as myself, don't usually get to see these until you become part of different storylines or storyboards where you are promoting new satellites, new ideas, new things. Then you're going to have to inform yourself of the rules and regulations, I guess.
So when did you first become familiar with, say, the 1967 Outer Space Treaty, for example?
Okay, so I think There's a good question. This goes back to I think 2015, when for one reason or another we started looking with a bunch of colleagues at a potential different format for science in space. So science has always been done through large space agencies, so ESA, NASA, and more recently India, China. There are a lot of other realities which participate. But the one thing ties all of these together and hasn't changed, the fact that you have to be either you have to be in a spacefaring nation, or you have to sign up to an agency like ESA, which has a given membership, a given priority based on the money that is poured into the agency. So there are many countries who don't have access to space, who would like to. So this is point one. Point two has been the case both for NASA, for ESA, where as a human race, we strive to do better, learn more, more in detail. And the process of doing that makes things more expensive. When you're making a satellite, it has to be bigger, it has to be better. And there are plenty of cases in the past where a mission was just fine as it was in terms of performing and it had an oversubscription of people wanting to use it for their own astronomical, astrophysical investigations, and not having the ability of doing so. Feeding, let's say, quote, feeding off the scraps of other people's investigation, which is, effectively not allowing people who are great potential to realize that potential. And so we thought of a potential commercial view, like a private venture endeavor, whereby you could think of a cheaper, smaller satellite to do a similar thing that had already been done, but maybe not as well, because it would be sufficient for a lot of different science cases. Now, those words, sufficient, not as well, those will never get a proposal past the door if you're trying to build something for a space agency. But there are a lot of people who would be more than happy to have a, quote, poorly performing Hubble Space Telescope in comparison. So this is when we started to inform ourselves of what's out there, what's feasible, and it revealed this wealth of capability that the private sector has. And as you pointed out, and we were late at the game because Earth observers had already been doing this for a decade, which is why you pointed out this increase in satellites. You had companies putting out 120 CubeSats doing real-time imaging of the planet, real-time, let's say an image per day. When back in the day when Google Earth, I think, first started, you'd be lucky if you had an image which was 5 years old in some cases. So this is where we started to inform ourselves, and suddenly you start realizing there's a bigger picture. So it's not just the Outer Space Treaty in 1967, it's the Moon Treaty or the Moon Agreement in 1979, and now the Artemis Accords, and suddenly there's this layer of treaties and agreements which are patches, some a bit sketchy. And on top, there's an underlying current of all of the different political things which have been happening. And so it's like this mix of geography and history and politics, which is actually quite interesting and intriguing. And I'm sure, you guys know much more about it than we scientists do.
So you have a kind of an influx of private actors into this space, which perhaps was sort of quite sort of moribund in a sense. There wasn't an awful lot of agility and innovation going on. Would that be a fair assessment of sort of the earlier, when it was very much an interstate domain?
I don't know. I would say I mean, I would agree that moribund is probably the status that space activity for the purpose of sort of exploration and sort of novelty applications because you had plenty of telecommunication satellites and plenty of Earth observing satellites, weather forecasts. That's never decreased to my knowledge, although that's not my field. So I could be misspeaking here. But then I think what happened was that many state actors realized the potential of tapping into the resources of private venture, just the way in which they could, I guess, capitalize on capitalism, if you can, if you allow the pun in a sense. And then you have, actors like Starlink, Elon Musk, Jeff Bezos, and all these people, but also a lot of other smaller companies that see a way that they can both do similar things alongside state actors, but also partner up. And I think that has been the real boost, be it positive or negative, but that has been the real boost to the sector, which was finding ways in which the state that sometimes does things in a more expensive way allow company to help out. Now, it's a double-edged sword, like in many different things. We don't have to mention the NHS here, but there are things that when you start privatizing, you lose control. That's always been the case, I guess, to some degree. So, I can think of many positives of that kind of revolution, but not necessarily. So that's to answer the question of how did it go from being moribund, if you will, or with the fewer satellites to this sort of boost of numbers, bearing in mind that these numbers are numbers of smaller objects in size, and only in the last 3 to 5 years we have seen now capabilities, for example, for SpaceX to deliver very, very large payloads. That has been a real change in paradigm, in a sense, because before you would have ESA maybe enabling small manufacture of CubeSats and people training, small companies, SMEs training to do their little payload or their little CubeSat, their little attitude and control system. But now we're looking at a private company which is taking the role of NASA to deliver supplies to the International Space Station or moon trips. It's a completely different game now.
Yeah, I understand that Elon Musk's SpaceX Starlink satellite now make up almost 60% of the entire space constellation, and that at current rate Starlink will become the major dominant force in space, and that seems to have happened pretty quickly.
Yeah, it has. I think this is where, to some extent, I think global. I'm gonna bring it back to the global governments that where you work. But the thing that on one side we feel enthusiastic. I mean, you can see even the younger generations that you follow the successes of someone who tries and fails a bunch of times in order to learn, and then eventually become extremely successful. I mean, we're all behind that attitude, and long may it continue to some extent. But and there's a but here, one has to be careful of the trajectory, in a sense. So it's I welcome the fact that the state can find cheaper ways in this way of doing things, and SpaceX has been amazing. But one has to also be aware of the effective gold rush that's been happening on space and its resources. And when I say its resources, people immediately think, oh, mining and that, which has a role, and we can talk about that. But orbits are a resource. Space is vast, but it's also when you don't have to think of it as the size of the object and where it sits. When you think of space, there's no such thing as stationary. Everything is in orbit. Everything is in motion. So an object, be it a screw that's been lost of a centimeter or a large cargo, it has a velocity, and when I say a speed, right, and that speed is faster than 5 to 10 times faster sometimes than a bullet. And so objects in space occupy a place and the motion that makes them exceedingly dangerous, and collision avoiding systems are now a real priority, and technically they are becoming their own independent business, funnily enough, because states are struggling now to keep track of everything. And you know, as you say, you know, there are disasters, Kessler Syndrome, one of them, which is only a couple of mistakes away.
So let's get into that a little bit. So the Kessler Syndrome, we discussed that before. You know, why is the Kessler Syndrome a perfect example of governance failure?
So the issue there is, so I don't know if people hearing this would know, the Kessler Syndrome is the case where someone predicted if two objects collide in space, then the fragments and the pieces would create thousands of objects, and which would then collide and just create a massive amount of debris that will make any surviving orbiting object almost impossible to maintain. And therefore also shut down the gateway to space, because you know, getting a rocket through as well has a potential higher risk because it's difficult to predict. We have had examples of this actually, and you can link that to the militarization of space. We can get that onto that later, but the risk of this is very tangible, because there have been cases of collisions, and there have been cases of anti-satellite tests which have produced thousands or tens of thousands of pieces of debris, a lot of which now also have decayed, but still quite a few present. And global governance here is going also back to the Starlink issue, is a situation where you know, humanity needs to be able to predict, be you know, 2, 3, 4 steps ahead of the game in a sense. And to be fair, I think, you know, from my very little knowledge of politics and society in a sense, we haven't been doing very well at this. I mean, a bigger and space is quite a linear environment, as in you see the film Gravity, just to make a point, right? You understand immediately what the Kessler Syndrome is and how it can happen. It is, you know, cause effect, you know, mistake or bad judgment consequence. Climate change is less linear, for example. You know, without getting into that topic, it's exactly the same. We are, you know, maybe one or two. I'm not a, you know, not an activist, but you know, we are 1 or 2 large oil spills or coral reef extinctions away from a runaway disaster if we're not there already. It's just so complex. Everything is so tied together that you know, even though we have evidence from the scientists, it's difficult to show it on a piece of paper and say, this is step 1, 2, 3, 4, 5, and that's it, we're done, right? And so global governments has a role in space, not just because it's yet another thing that needs to be managed efficiently. It's because it's, quote, easier to see the effects, and it's there for everyone to see in a sense. You know, it's right in front of our eyes. And it could be also a way in which to lead on how to deal with other things, you know, here on the planet, be it climate change, be it politics, be it resource sharing, you know, with the Arctic drilling that's, you know, currently being debated, or the Antarctica once the ices start melting further. And you know, space is there for everyone to see. So going back to the treaties that you mentioned earlier, so the 1967, correct me if I'm wrong here, because my memory is a bit sketchy now, but the 1967 treaty was signed by quite a lot of people because it was UN led, if I remember.
That's right, yeah. Yeah, it's got a lot of signatories.
It was like 100 plus, I can't remember. Obviously, the ones who tends to, I mean, I don't know if that one was signed by the major players, but the more recent treaties, the number of signatures decrease, as you see, because I don't know if it's the fear of missing out, but the one I like the most is probably the one that's signed by the least number of people, the Moon Treaty. It is very draconian in a good way, in a sense, because it sets some cardinal points which are unavoidable in the, you know, the demilitarization of space is I think, if I remember correctly, it's not equivocal. You know, it's kind of like this shouldn't be used, full stop. One of the reasons why very few people of the majors, you know, China, Russia, but US, UK, I think one of the reasons why they didn't sign it is because it specifically points out the resources, and by resources, again, I mean both for mining of the moon and asteroids, but also orbits, which are critical because they are, it's like parking spaces at the end of the day, they're limited. They are owned by humanity as a whole. They're international. So they're literally, saying private sector, great, but you can't, it's not a gold rush. You can't just plant a flag, just to quote Eddie Izzard, and say, I've got a flag, therefore this is mine. And as you can imagine, very few signed it. I mean, I have to take my hat off to, I had to check this before I came. France and India were the original co-signatories of the Moon Treaty. And if you think about France, the CNRS, it's, the Space Agency of France, is one of the best, if not the best, developed in Europe in terms of experience and capability and funding, probably. And India is now a major spacefaring nation as well. So hats off to their foresight in saying this is the kind of thing we need. I think, though, that was 1979, so maybe India might have retracted that now that they can, they can claim more. But the recent resurgence of this space has triggered something else, which is the Artemis Accords. And I've read them once when they first came out. Recently I've been trying to work out exactly what the all of the various controversies of that are, because my understanding is they do, if you read it does reverberate and bring back many of the 1967 points. So, I think it's a good starting point. The one thing I noticed different is the opening up to the private sector. So again, there's not much oversight. So they say that I think the regulations and the provisos and everything that's set out in the 1967 only applies to the private companies and private ventures if they are doing the bidding of states. So if the US or NASA asks SpaceX, please do this for us, like, bring a cargo to the ISS, they are still under the proviso of those interactions. But, if someone just wanted to, Jeff Bezos wants to do his tourism thing, he's not under any a state legislative framework that he has to adapt for. And therefore comes that point that you mentioned about the fact that there is now this dual state actor versus private company or multinational, whereby which jurisdiction are they actually following? And space law is still quite, I'm not an expert again, but there are quite a lot of loopholes, and things have been progressing so fast that I think the pace of progress in space is difficult to catch up with all of the various different legal implications that they have to sort of predict. What if this happens? What if that happens? And
that's very helpful, Giorgio. Okay. I think we've set out a very useful kind of framing of the complexity, actually, of space governance and of the very fast-moving dynamics in a field which is highly experimental, which has a lot of resources moving, in this direction because of its critical application to communications, both sort of within the social economic sphere, but also in the military sphere. I mean, I was pretty shocked to read that Russia tested an anti-satellite weapon in 2021, and essentially just debris was blown all across various, I think in orbits from 300 to 1,100 kilometers above Earth. So
yeah.
Okay, and I was wondering, how did the engineers respond? Was it one of those moments where
So let's do some context here. So since Sputnik and since the very first satellites, all countries started thinking, well, how can we stop this, just in case, during the Cold War especially, they used to bombard cities in a way that we can't control. And in fact, the first experiments to debilitate satellites was done from, I think, both US and Russia, where they started exploding nukes in the high atmosphere. This goes way back, I think, in the 60s or 70s. After that, I think it was the US in 1985 that did the first anti-satellite test with an F-15. It might have been 83, I can't remember. So they did, that was the first one. Then there was another one, again, in the US, but I think they had a reason for that, is because there was a 400 kilo satellite. I can't remember if it was a weather forecasting something, but it had hydrazine. So hydrazine is a propellant that allows you to change the orientation of a satellite. And it's highly toxic. It's extremely toxic. So there's like 400 kilos of that propellant that needed to, and so that's why they decided to burst it in space before re-entry. Also they say, but that's a good reason to. Then there was another test. So then there was another test, the Fengyun one, the Chinese satellite. They did that in 2009, but again, now it could be. I'm not making it up. I just can't remember the dates. There was an Indian one recently, and yes, it was a Russian one, 2021. I think the issue, and all of these produced tons of debris. I think the nuance here, where the media got a lot of, they put a lot of spotlight on the Russian one and the Chinese one. The nuance is that so first of all, why do they do this is to show that they can, because, the moment that you start claiming that a satellite has any other scope other than civil, the creation of Space Force, you could argue is one such argument, then you have to, the states that feel obliged to say, well, you can do this up to a point, right? Whatever, if being that bad or good, I'm not justifying. The nuance is, if you do that on a satellite which is at 300 or 400 kilometers and therefore just about to re-entry, if it's not correcting its orbit, then chances are that the majority of the debris in a 15-20 year range will eventually decay. If you do it higher up, like for example, what happened with Fengyun one, or I can't remember the Russia orbiting satellite, what level it was. Then there's a risk that you create thousands of fragments which will stay in orbit for decades, and that is where a lot of the people will have complaints, problems, because it literally creates a legacy of it's like an oil spill that you can't clean for 50 years. It's just it's just a no-go area effectively. So I think there's that nuance as well. But yes, it does goes to show that space has become like the seventh continent in a way. As scientists, we think of it as such a precious thing, such a precious resource, that you would argue the United Nations needs to get their act together and say, you can't treat this like just a new area to colonize just because there's no one living there. This is something that belongs to humanity. But I think the UN's got its own problem at the moment. So
indeed, they've got a lot on their plate, that's for sure. But this seems important, I think.
Yeah, it is. There was something. There was I can't remember now. There was something that mentioned, I don't know if it was the Artemis Accords or something else, where again private sector has the capability of using all of the various different from traveling to planets, traveling to comets and asteroids, but also things like using L2. Now, L2 is a second Lagrangian point. It is an absolute key position for doing scientific observations. You have all sorts of different satellites which are parked there. I mean, it's a big space, don't get me wrong. It's like, 1 million miles in diameter, roughly, the orbit. But it is a key resource. It's like one of those, it's like a gateway for things, and to allow companies that have minimal minimal, they will have some betting, but they don't have to go under any oversight. And moreover, they're not subject to specific legislation. To just use these resources seems a very dangerous game to play.
Right, yeah. And the Artemis Accords, are they soft law? They would not be binding on state parties.
I think yeah, that's correct. I mean, you're the expert there, but I think that's how I understood it. They as I said, they reverberate many of the 1967 points, and you could argue their hearts is in the right place. Apparently, some of the major players haven't. I've been reading. I haven't come to this conclusion myself. The reasons why some major players haven't signed or ratified these are because they seem to be quite US-centric. I can't exactly explain as to why. I do know that if someone wants to join, they have to communicate this to the US government rather than the United Nations. And that I did read, and I'm not quite sure why that's the case. I mean, you would argue that even though the US have done the leg of writing this up possibly because of this set of endeavors that in the next 10 years, they plan to get 100 launches onto the moon from private companies. So it's in their best interest to put framework there at least a few years ago. I wonder why it wouldn't have just been handed over to the UN saying, can you please, ratify this as to make it your own domain of, maybe we need another body, another global governance parallel to the UN, but for space, who knows?
Yeah, perhaps some kind of planetary or off-world governance body. I mean, I'm also aware that the International Space Station is due to be shut down. I think that's scheduled for 2031. And of course, the space station for many decades was sort of a symbol of international technical cooperation among scientists from all over the world, including, of course, among scientists across the divide of the Cold War between the Soviet Union and the US and their allies. Perhaps you could sort of try and put that into this context that we're discussing here. I mean, symbolically, what does it mean that the International Space Station is scheduled for shutdown?
This is, this is a huge thing. I don't know if the powers that be have a very specific plan, and they very well might, as to what comes next after that. I know that for me, the ISS has always been a source of inspiration exactly for what you said, that, the scientists in their endeavors, they look past the political borders, they look past their differences, and they learn from each other. Scientists go there also, astronauts who speak 5-6 languages and learn about each other's cultures. And there's a sense of cooperation, even during moments of tension in the Cold War. We were still getting lifts from Baikonur and the Mir, the Russian rockets and vice versa. So this has been a huge sense of inspiration, and the fact that is coming to an end in a period where political tensions are growing is worrying, I guess, and a little bit sad. One hopes that there is now a Chinese space station, I think, that's also starting to be put together. I mean, I don't know what stage it is. I haven't checked recently, but there's a possibility that a different kind of cooperation, even though that's a national asset, as far as I understand, it might be that in this new, in this emerging BRICS nation might start to view the possibility of having that kind of international, so like nucleating a new international agreement, which is separate, independent. But ideally, you would want something like the United Nations, something which is truly international, without borders to really. That's what we should have: astronauts without borders, I guess.
That's pretty good. Yeah, you heard it here first. So I like the analogy between, the Kessler Syndrome and a sort of a catastrophic oil spill. That actually makes a lot of sense. I was just wondering whether we might play with another analogy between, say, regulation of artificial intelligence and space governance. And I propose that for two reasons. I mean, one is that you have this incredible kind of creative destruction going on in this space, as you said, capitalizing on capitalism, right? You have the Elon Musk, the Jeff Bezos, who are really sort of breaking through frontiers, putting an awful lot of financial investment behind the very best engineers and scientists in the field, driving this technology forward, and indeed being encouraged to do so by governments. This has, I imagine, critical applications in all sorts of ways, from, say, 5G systems or 6, 7G or whatever it's going to be. Maybe other kinds of technologies, nanotechnology, and these other sort of, I think you mentioned earlier or in another conversation, space-based solar power, for example. Right, so we have this incredible kind of industrial zeal going on in terms of economic, societal, technological applications, But on the other hand, we also have sort of this dual use feature, which is that this also has applications within the security military domain, that a lot of this technology does have the potential for dual use. So in artificial intelligence, we might talk about autonomous weapons systems, for example, which have been incredibly difficult to advance any regulation to curtail innovation development in that space. And I wonder whether some of those dynamics perhaps are reflected, echoed here in the space governance domain. And I suppose the provocation might be that that all of this incredible activity by engineers and scientists that are pushing forward towards a system which could certainly serve a global public goods purpose has to also be aware of the fact that you have this security domain, which in a way has its own autonomous logic, which is running in parallel. And it's here perhaps where some of these tensions are manifest. The growing militarization and geopolitical context is impeding the possibility for actual regulation to ensure cooperation, collaboration, and safety over, say, other motivations, whether those motivations are winning the space race in military terms, or profit maximization might be another important motivation going on here.
Yeah, I mean, you've touched on a very large range of subjects with some common schemes. I think if I can pick on the last thing you said, I think greed is effectively one of the biggest forces. We know that from all sorts of different other aspects, and it's no different here to some extent. There is some element of people playing with toys. That is, if you think about space tourism, it's something that has has inspired and wondered a lot of people, and people who become millionaires, billionaires, they say, well, if there's one thing I want to do is this. And as I said, it's a double-edged sword. There's an inspiring aspect to that, and we're happy that this keeps inspiring. But it's checks and balances to some degree that you'd expect some form of law frame to be there to pick up the pieces if something goes wrong. And I think this goes back to that discussion. AI, as you say, is, of all of the things that we've discussed so far, is possibly the most rapid technological advance that there's been, in humanity. And there have been many technological advances in the past, but if you see the span of time in which this is happening, it's just a runaway process at the moment, and you just can't keep up. And you could do another parallel between space and the internet. What happens on the World Wide Web. The laws we've always been behind in trying to regulate that. Some people advocate for no regulation, right? And so AI is pretty much similar. The difference here, if I have to pick on one particular difference, is what are the consequences in terms of what is put. We still have, maybe not for long, we still have control of which sectors and what application is AI being put in charge of. And as we know, these systems aren't perfect. You could argue that there have been many an application where after long trial and error, they absolutely outdo and outperform humans, and that's probably very short. But you have to think of what trial and error means in certain cases. What are you putting them in charge of? So if you look at car accidents and Teslas and things, you would argue that one accident of a Tesla, even though you don't know who to blame because AI is in charge. But when you do statistics, you'd say, well, human errors are 100 times more damaging effectively than having self-driving cars. And that has minimal impact. Now, if you were to extrapolate that and you're putting AI in charge of launch codes for ballistic missiles, would you want a couple of mistakes of those? That's not something that you'd be able to reabsorb easily. And the same, I guess, goes to space. When we say, or climate change, what we were saying, that if you are one or two mistakes away from a possibly unrecoverable situation, be it the Kessler Syndrome or climate change, How have we dealt with as humans is to try and think 2-3 steps ahead. When you're planning an oil rig, you try and put all the safety measures in place. When you're planning space missions, you've got all sorts of different, I mean, ESA makes you jump through so many hoops when you're doing, and rightly so. NASA probably the same. But that's us dealing with humans making errors, and you can try and be 2, 3, 4 steps ahead. When AI calculates 20 steps in a fraction of a second, there is no being ahead of what they're capable of creating, in a sense, which is why, you know, you wouldn't necessarily put maybe AI in charge of markets or other things which have so many different implications on the livelihood of the people. It's because once those decisions are taken in fractions of a second, there's no, you know, stopping the fallout.
Right. So perhaps just to extend this analogy a bit further, I mean, we haven't had a major international treaty, a binding treaty on space governance since 1967. The climate change space, obviously, we have an awful lot of diplomatic activity there. We do have treaty instruments, some binding, like Kyoto, some more voluntary, like the Paris Agreement, but with some binding elements sort of mixed in there. But we have an awful lot of public pressure to do something. We have the Conference of Parties each year continuing. Obviously, there's a lot of people who are very alarmed at the lack of inaction in terms of doing something systemic or, you know, actually really driving forward the transformations that many regard as necessary in the climate space. But when it comes to space governance, I don't think there's much public outcry for the lack of regulation in this space. So how might it be possible to make the case to the public or through public advocacy of the vital importance for space regulation, space governance?
So, I mean, the way I see it, I think there might be 2 issues here, and they're both like an obstacle in a sense. One is the perception of people that space is something which is far removed from their daily lives. That, you know, they think, well, okay, so that's where you'll do science or where there are potentially military assets, and yeah, I get my weather forecast from and you know, they think that's it. Sometimes the awareness of how much space is actually affecting daily lives, you know, not just your sat nav and your GPSs, but there's all sorts of other applications, agricultural and livestock planning. There's all, you know, flooding, disaster management. I can't remember the exact name of the institute that we have even here at UCL that looks after these things. So one is, I guess, that there needs to be sensitization, how do you call it? Making people aware, an awareness campaign of how much space does matter. Although, you know, I still appreciate that climate change is much closer to home, and therefore that's rightly where people put their attention. The second thing is, again, it's one of the fact that the deregulation has always been seen, and, you know, this can quickly spiral into discussion of more direct politics rather than space, but the deregulation has always been seen as an enabler, because it says, you know, you remove the rules, people can do more, or you get more people to do stuff because they are less constrained. But, you know, it's also an argument for chaos. You know, regulation is not there to constrain, it's to protect. People who have, I mean, I'm sorry to bring it back on the point of space tourism that we've already touched on, but, you know, you look at people who have gone to space. Once upon a time, they were just astronauts. And you would say, well, you know, they are a very peculiar set of people who have gone through rigid training and everything, but they, you know, they're schooled in that way. But now you have people like Jeff Bezos who send random people up as long as they got the money. Okay, so, you know, so they all fit the category of being rich. But,
they sent up Captain Kirk, didn't they?
I was getting to William Shatner, which is, you know, he comes back, and if you read his, you know, apart from the tears he had as he got out, happy being alive, but if you read this interview that he gave recently, his words could have been from Buzz Aldrin or anyone else. He said, you go out there and you see how beautiful, but also how hostile space is, and how precious the cradle of life is to us. You know, the planet Earth is so small in a sense when you look at the wider space. And for all our endeavors in trying to find Earth 2.0, which we like to discover, there's no moving there anytime soon. And so it's about protecting our resources, be them, there's no planet B. I think there's an activist group that signs up with that name, right? And the same goes to space to some extent. So the lack of regulation is something that people should be worried about, if anything. It's like the California gold rush all over again, in a sense, and it's just trying to get there first. We live in a world where IP matters, where intellectual property is protected because it means wealth, it means resources. But put that into space, and immediately you have a situation where you're thinking of, well, I'm going to do this first, and therefore everyone else who wants to do this has to pay me. It starts to sound a little bit trivial and almost childish when you're looking at the vastness of space and the wealth of knowledge and capability that we might be pursuing by going into other planets and asteroids and comets. So I am all for I and many others all for the increase of activities and the mining of asteroids, but not to push the agenda of maybe a few multinational corporations that want to make money out of this, but in a way of finding alternative resources to the ones within our planet. So I guess when it comes to prioritizing, to be coherent, because you can't advocate for one thing and then one another, I guess finding cheap and clean ways to launch is a big priority. The next generation, or this generation as well, but the focus should be on trying to find ways of getting to space in a cleaner and cheaper way. And then for sure, mining and finding resources and ways of exploring, we're all for the dream and the vision, but in a way where we protect the planet, not destroy it in order to lift off, let's say.
Well, I think we're drawing to a close, Giorgio. I want to say thank you so much for laying out such a rich landscape. There's so many threads that I think we could follow up on here in terms of what's going on in the space governance field. I suppose, the Wild West does come to mind a little bit in this context. I think you've given a very good sense of that we may be sort of really approaching a critical moment where this conversation has to really be amplified. That the pace of development and all of these different actors getting involved into space exploration, there is a real need that this, what we might call a governance orphan issue, is attended to. I suppose to close, I might just ask, how hopeful are you that scientific integrity, that the safety of space experimentation, that these challenges can be grappled with? And to put that perhaps in a slightly grander frame, in the course on global governance that I teach, I often use the ethos and some of the stirring quotes of Buckminster Fuller, who was sort of this great scientist, engineer of modernity, an American who was very prominent in the 1960s and 70s, and essentially, was very pro experimentation, pro innovation, but also did offer some cautionary advice. And one of the quotes which has stuck with me is this idea that humanity is acquiring all the right technology for all of the wrong reasons. And I wonder whether that resonates.
Yeah, I guess to some degree. I mean, technology is a funny thing. You look for something, and sometimes you find something you don't expect. And to go back to the point that you made about dual use, a lot of scientists and engineers, they will see what they need, and they will build what they need in order to get to a particular point. And it then comes to the responsibility of other actors, be they state actors or private companies, to yes, make the most of that. There's always there's always a Tim Berners-Lee in the background, or someone who's trying to sees the vision and makes something out of it. But that's where global governance comes in, right? To make sure that those uses remain peaceful and appropriate to some extent. So to answer your first question is, I think we should all remain hopeful. I mean, hope is the one thing we have. No one can take away. Hopefully, and hopefully that can be achieved by extending the conversation. So getting the people who are capable, like the Elon Musks, or the people who have the capability, getting them to be part and parcel, if not central, to these conversations and the Artemis Accords, not in order for them to, stick in a clause to make more money out of things, but to leave a legacy. If that's what you want, if you want to leave a legacy, be part of the conversation and make sure that, humanity looks back and say, this was a true hero of our time, not someone that, managed to tweak things for their own personal benefit.
Thanks for tuning in to Imperfect Utopias or Bust, Global Governance Futures. If you liked this content, please do leave us a comment and subscribe. If you're new to the show and you want to get a list of our favorite books, other resources, listen to past shows, and to join our community, go to ucl.ac.uk/global-governance.